Crown ethers are cyclic polyethers. They're typically named as X crown Y, where X is the total number of atoms in the ring, while Y is the total number of oxygens in the ring. As an example, we have 12 crown 4, which has 12 total atoms, as well as 4 oxygen atoms, and so it is named as 12 crown 4. We also have 15 crown 5, which has 15 atoms, as well as 5 oxygen atoms, and then 18 crown 6 shown here. Each of these crown ethers has a specific size in the cavity inside of the ring, and so it's able to coordinate to different cations, binding specifically to certain size cations. For example, 12 crown 4 can bind selectively lithium. 15 crown 5 ethers can selectively bind sodium. And then 18 crown 6 binds potassium selectively over the other cations, which are smaller. One of the applications of crown ethers is that they are often used as additives in organic reactions to help dissolve certain ionic compounds. As an example, if we wanted to do an SN2 reaction between an alkyl halide, which is organic soluble, and sodium acetate, which is ionic and water soluble, in order to have the two mix well, we often use a crown ether, such as 15 crown 5 ether, which is able to dissolve sodium, and as a result, it will help dissolve the acetate ion into a solution with diethyl ether. And as a result, we can get a effective or productive reaction between sodium acetate and this alkyl halide. Certain natural antibiotics behave similar to crown ethers. Here's an example of nonactin, which is an antibiotic that is able to bind potassium ions selectively over other types of ions. It is an antibiotic because it's able to bind potassium and bring it out of the cells of bacteria by helping potassium cross the hydrophobic cell membrane that the most bacterial cells have. And as a result, it eventually leads to the killing of the bacteria.